Hello students, in this part of the lecture we are going to understand about what is acceptance angle phi and what is numerical aperture, why it is important for the fibers. First let us see acceptance angle. You can imagine a fiber end is cut perpendicular to its fiber axis and a light ray enters into the fiber as shown in the diagram. Now it makes an angle theta with the fiber axis and it suffers a change in direction when it enters into the core. When it reaches the core cladding interface, you can understand if the angle of incidence at this point is greater than critical, then only it can propagate with the principle of total internal reflection. Now, if any angle is greater than the one which is marked, which we call it as acceptance angle, we can consider a second ray which is greater than this angle. For the second ray B, definitely the angle is greater than the first ray which we have taken as A. Now what happens at the interface? This angle of incidence in the core cladding interface is going to be less than critical angle. So as a result, it just refracts into the cladding. It won't be propagated through the fiber with the principle of total internal reflection. So once again we try to understand what is acceptance angle. So it can be defined as the maximum angle with the fiber axis up to which a light ray can suffer total internal reflection so that it could be propagated well into the fiber. Now next part of the lecture we will understand what is numerical aperture, how it is important while propagating the light ray through the fiber. You can see the diagram. The ray enters with an angle of theta 1 with the fiber axis, and refracted angle in the core is marked as theta 2, and we can consider a triangle ABD, and this angle could be understood as 90 minus theta 2, or we're going to mark it as greater than C. This angle can be greater than critical angle, and we can understand that as 90 minus theta 2, and theta 2 can be related with the critical angle as 90 minus C. Now for this refraction at A, you can apply this equation based on the Snell's law. That is NA sine theta 1, that is marked here, and N1, that is the refractive index of the core, and sine theta 2, that is, we actually know we have used this critical angle and we got the relationship between C and theta 2. Now we are going to substitute the value of theta 2 here and the value of NA. For example, refractive index of air is taken as 1, so we get is the equation theta 1 is equal to N1 sine, instead of theta 2 we are going to have 90 minus C. Now this equation can be understood now using the other equation. We can have a relationship for cos C, that is 1 minus sine square C. So using the equation sin C is equal to N2 by N1, that is N2 of cladding, N1 of core, we can change this equation